Hello, everybody. What we have here today is a queue. So we talked about stacks and queues. This is the queue version of this. So this is the code that runs a queue. A queue is, as we've discussed, basically a line. People can get in line. The first person in the line gets out. Anyone who wants to get in the line gets at the end of the line. So here we go. This is the, or I should say, my interpretation of the queue, because there are several ways you can write this. Now, a queue is a bit more complicated than a stack, you'll note. If we look here, it's actually quite a bit more lines in the stack, because there's a lot more stuff going on in it. All right, so we start off, and if you look at the stack, you'll notice that it's fairly similar here. We still have a max size. We set that max size. We have a front, a back, a size, and the list. So the size is the current size. The front is location of the first person in line. The back is the last person in line. The size, current size. And of course, this is our list line that holds the queue. So the stack and a queue are essentially a list or an array with some extra rules on top. That's essentially what we've built here. Now there are two functions that are used with the queue. There is enqueue, which you see here, and there is dequeue, which you see here. Enqueue puts things in the line, dequeue takes things out. And of course I have a little display here that displays information. And I have a main that will display my main stuff. Basically run the whole program. So let's look at the enqueue first. The enqueue puts things in line. So we start off with, define enqueue here. We're going to put whatever we put inside is going to be called item. Now, if the line is full, that means if the size is equal to the max size, well, the queue is full. I can't put anything else in the line. If the line is completely empty, well, then I just put the item in there. Since it's empty, I add it to the list. And I can just use this dot append because the whole thing's empty. So since it's empty, I can just go ahead and put it in the 0 slot. That's what I'm doing here. Now, if it's not empty, then I have to do a little bit more work to figure out where I need to put this. Because the way a queue works, even though it's essentially a line, or I guess an array, my front and back will move around, and then they will loop back to the front again. So I still have 5 slots. So I'm making this kind of circular list to kind of go around it. So you can kind of imagine it as a circle. People standing in a circle in line. So in order to figure out where the front and back are at any given time, I come here and I say, all right, well, putting the item in line, and this means I can actually put it in there because it's not full. The back is going to equal, or I should say, the new back is going to, I'm basically just going to add 1 to it. Now this percentage self max size, the percentage is a modular arithmetic. So if I were to say, for example, 20 percentage 5, that answer would be 0. Basically, you would subtract 5 from this as many times as you can until you can't get anything left. So if I said 23 percentage 5, I would subtract 5, and that would go to 20. I'd have 3 left over. It basically just finds the remainder. This is how we move ourselves back in to this array, make sure we don't go out of bounds. Once we hit 5, which is the max size, we shift back to the front again, basically using this. So if this goes up, let's say if the back is in slot 4 right now, I increase it to 5. Well, 5 mod 5 is 0, so now the back is in 0. This keeps track of basically our 2 pointers that are pointing to the front and the back. Then I insert, and this insert here will insert at that very specific location the item that I want. And then I just increase the size by 1. I've already increased the back. And the front doesn't need to move because it only moves when we're taking things out. Whereas this moves when we are putting things in. And there you go. That should put things into our line. We go down to DQ, which takes things out. Our first option here is obviously, well, if the line's empty, we can't take things out. So it's empty. If it isn't empty, then we have to do a little bit of work here. My R value here is just going to hold that particular item that I'm trying to get rid of. So the list, and I find the location of wherever the front is. And then I use this remove to remove that particular value. So it goes away. Boop. I print removing that value. And then I change the front to basically go back one more, or go up one more rather. And then I change the size. And then you notice this return, it's not necessary, but I'm going to return what I took out so I can store it somewhere else if I need to. So if something comes in the line, we're empty, or rather I should say if something's in the queue, let's say in slot 0, there's only one thing there, I want to remove it. So I come in here and I basically put that value into here, and then I remove it from the list. It's gone. No longer there. Then I adjust my front, and for some odd reason looking at this, I think that perhaps should be -1 to the front instead of plus. Well, let's run it and see. We'll figure it out in a second. Maybe I'll change that and see what happens if it breaks. And then of course the size goes down by 1, meaning we are essentially, 1 less. And display displays things. If it's empty, of course, we can't display anything. If it isn't empty, we basically have a little loop that goes through and prints each item. And I'm doing all this, 1, 2, 3, 4, so we should be able to see the whole thing. Now I've got several DQs, NQs, and stuff down here already. So what I'm going to do is I'm going to comment out some of these, and we'll just walk through them real quick. All right, and we'll leave the display there. I'll just NQ these 3 first off, and we'll see. All right, well, there's my queue. There's the front of the line, and we go on down. Okay. I add in this guy and this guy. That should fill the queue. So you see, putting it in because it's empty, so we know where it's going. 20, 30, 40, 50. We got those. If I were to NQ 60, well, it's full. It should tell me that the queue is full, right? If I DQ something, that means 10 should go away and 60 should go at the bottom. All right, well, let's see. I don't have a print for that yet, so let's fix that. All right, 10's gone, 20, 30, 40, 50, 60 is in the list. If I DQ again, that should take 20 out. And of course, we'll NQ 100 and we'll display it all again. So I should have 30, 40, 50, 60, 100. 30, 40, 50, 60, 100 in my queue. So there we go. I put it in, took it out. That's essentially how the queue works. I said before I thought this looked a little odd. Maybe I'm wrong, but let's find out what happens if I did make that minus. And this is a very common error when writing code, to put a minus instead of a plus. Let's see. Oh, wow. Okay. We got 30, 40, 50, 60, 100. 30, 40, 60, 20, or 120. Suddenly we have the 20 at the bottom. So that's what's happening here. Removing 50 from the queue. Okay, that's way out of whack, as you can see. So one little mistake there, and all of a sudden, I'm pulling the wrong things out, essentially. Oh, there we go. That's better. Now, part of this class, or what we're doing here, is knowing how this code works. And if I said I wanted to in-queue and de-queue these things, you should know what the stack and the queue look like at the end. But that is our code for our queue. So if you have any questions or anything like that, feel free to ask. Otherwise, that is it.